Hello everyone and welcome back to a new video. In this video I'm going to be showing you how to make a pet system where you can equip an infinite amount of pets, and we're also going to be covering how to make these nice walking and flying animations for the pets. Also, if you guys want to support me and want to have access to all of my project files without having to follow the tutorial, they will all be available on my Patreon in the $10 tier. The link will be in the description. Okay, so the first thing we need is a pet to work with. So let's say your pet has two parts in it. So let's say your pet consists of these two parts. I'm gonna have one set to a size of 2, 2, 2, 2, sorry, 2, 2, 2, and another part which is just going to be this. And let's say that this is your pet. Now, of course, this is not a pet, but this is just a. Let's say that your pet consists of multiple parts. We're just going to group them together by selecting both of them and Control G. That's going to group the model, and we can rename the model to a name, so pet. And what I can do is have a part that's going to be a primary part. So here's how this works. This is going to be the primary part of the model, and it needs to tell the script where the front surface is, so where the front of the pet is. So what I'm gonna do is add a decal to this part. That's going to be the primary part, and as you can see, the face. So I selected front on the face, and it's telling me that the front surface is this. So that's where the pet is facing, which is correct. So I can just get rid of this decal. This is just an indicator of where your front surface is. And what I can do is rename this part to primary part. Now this part is going to be invisible, and it will cover your whole pet. So I'm just going to make it cover the pet. That works. Okay. And I'm going to set its transparency to 1, and make sure that can collide is unchecked on every single part. So what I'm gonna also rename it to primary, not primary part. Primary. Now we can make sure that all of the parts are not collidable, so make sure that every single part in the model has can collide turned off and anchored turned off, except for the primary part. Now the primary part can be should not be collidable, just like any other part. It should not be collidable. But the anchored property, however, should be set to true only for the primary part. Now what we can do is set the primary part of the model. So select the model and just click primary part and click on the primary. Now what we can do is if you play this right now, the model is just going to fall apart. Yeah, that's what happened. So what we need to do is make sure that the primary part is the only anchored thing, and the other thing we need to make sure is to add a weld constraint to it. Now part 0 is going to be my primary part, and part 1 is going to be the first part of your model, and then add another weld to duplicate that one. Part 0 primary, part 1 to the other part. Now all of the other parts are welded to this primary part, which is so now if you run this, it will not fall. So everything works fine. So this is going to be my pet. I might as well just make it look a bit better. I mean, it's ugly either ways, but we can change a little bit. So we can make this neon. We can make both of them neon. I guess that makes it look a little better. Probably not, but it will do the job. Okay, that's too bright. That's really annoying to look at. I should have probably just left it how it was. Yeah, that's going to be my pet. But I also would like to resize this pet, scale it down a little. So I'm just going to compare it to a humanoid. And yeah, that sounds about right. That looks right. Now we can just get rid of this. So this is going to be our pet. I'm going to put it in replicated storage. Now here's what we need to do. We need to add a folder in the workspace, and it's going to be called player pets. Player pets. Now we're going to add a script to server script service. This is going to be called pets server. And I'm just going to get players. So players equals game get service players. Now we need a function for player added. Just type everything the way I do. So player added player. And players.player added connect player added. We can call this function, but also before we do that, we need to loop through um, every single player for underscore comma player in players get players do task.spawn function, and we're just going to call player added player, and that will work. So what we are doing here is just getting this is players, it's a service, and we are looping through. We have this player added event, right? And whenever a player is added, it's going to call this function. But here's the thing: if you had a wait over here or something, if you had anything in your script, or maybe it could happen without the wait, but basically this player added event might not be called if you had a wait, and so we are looping through every single player and calling the player added event, and this will not run if this ran. Okay, so now what we need to do is create a folder. So for each player that joins, we want to have a folder in here, in the player pets folder, that contains their pets. So for me, it's going to be Polaris prog, so it's going to look something like this. And when they leave, we need to get rid of that folder. So we need another function, silicon function player removing. That's going to take the player, of course. And now in here, players dot player removing connect player removing. Okay, that's all we need for now. Now, whenever a new player is added, local folder equals instance.new folder, and folder.name equals player.name, and folder.parent equals workspace.playerPets, which we might as well just leave a variable to. So player pets equals workspace.playerPets. Now this is just going to be parented to player pets. Now if I play the game, I should have a folder in here called players prog, but when I leave it will still be there, but you can see it because I'm in studio. So what I'm gonna do here is just local folder equals player pets find first child player.name. Now I'm gonna check if folder equals nil, then we're not gonna run any of this, so we're just going to stop there, return, and if so, then folder destroy, and that will work, and I should not have any errors. So I have my folder right there. If I leave, the folder will be gone and no errors. Okay, good. So that's our server script done. Now we need to get to the client side. So I'm going to have a script in starter character scripts, and it's going to be called, or maybe in starter GY, I'm not sure. We could have it in starter player scripts. This is going to be pet follower. This is what's going to make pets actually follow the player. Okay, so we're gonna delete this print hello world here, and we're gonna get the services that we are gonna need. And the only service that we're gonna need is run service. So game can get service run service. Now we can get the player pets, which is workspace wait for child player pets, and we are using wait for child because we are on the client. So now we need to get math.pi, which is a full circle, but we need to multiply by 2 to give us actually a full circle. So local circle equals math.pi multiplied by 2, and I'll show you why we need this. But for now, let's just have a function called position pets, and that's going to take a character and a folder. Okay, now the next thing we need to do is run service dot render step to connect function, and we just need to loop through every single folder in player pets. So for underscore comma let's just say pet folder in player pets get children do, and local player equals we might need players service, so local players equals game get service players, and local player equals players square brackets or find first child player folder dot name. Okay, now if player equals nil, then we can just continue with the loop. And then what we need to do is get the character. So local character equals player dot character, or player dot character, or just player dot character. Now if character equals nil, then continue end. And what we can do now is call the position pets function, and that's going to take the character, of course, and the pet folder. Okay, that's all we need. Now in here, what I'm gonna do is for I comma pet in folder colon get children do, and I want to have a variable in here called default radius equals, and I want to have that at 4. 4 is a good value. And now we can get the actual radius, which is going to be default radius plus hashtag folder colon get children. Now, what are we doing here? So we are looping through the folder that we sent, so through every pet in that folder, and we are basically just choosing a radius between the player and the pets that will be surrounding them, and that's going to be the default radius. I think a better name for this would be minimum radius, and this is going to be minimum radius plus hashtag pet folder colon get children. That's just how many pets there are. And I found that that works pretty well. Now you could multiply this by something to add more space in, and I would recommend you do that on parentheses right here. You could multiply that by something like 1.2, but I think just letting it like that is pretty good. Okay, now we need to get the angle in which the pet is going to be. So the angle is going to be I multiplied by, and the circle divided by how many pets we have. So hashtag folder colon get children. Okay, now we need the x position, so local x, and that's going to be math.cos. So the cosine, so math.cos, and the angle, and we're going to multiply that by the radius. And local z equals math.sine, math.sine, and angle, and we can multiply that by the radius. Okay, now I think that's all we need, really. So yeah, now we can just create a c-frame. So local pet c-frame equals pet.c-frame colon lerp. Should we lerp it? Yeah, we should. So pet.primary part.c-frame, sorry, pet.primary part.c-frame colon lerp. And that's of course going to be character.primary part.c-frame, so character.humanoid root part.c-frame, and we can multiply that by c-frame.new x. Let's just give it a 3 on the y, and z, and that's all we need. Then we can just do, actually we need the lerp parameter, so 0.1 would be good. And now we can just do pet colon pivot to, which is the new set primary part c-frame. Okay, so pet c-frame. Okay, now I'm going to play the game and see if that works. I'm just going to get this pet and put it in the workspace so that I can drag it inside of the folder. Now I don't get any errors yet, so I'm going to take my pet and put it here, and as you can see, it's following me. If I duplicate it, I can have infinite pets, and that's pretty cool. But it's pretty bland right now. It doesn't have any animations, and it's also, the pet is also very high up in the sky. So we can add a local y offset. That's just going to be something like, actually I just want to type this like that. Maybe like 1.5. Let's just put in y offset, and let's play the game now and see how that looks. I think it's gonna be pretty good. No, that's still too high. Maybe 0 is good. Or maybe we can have a y offset set for each pet. Or we can use a raycast to position it perfectly on the ground, but I think I'm gonna do that in another video. Okay, so yeah, that's perfect. That's good. So y of 0, or even less, actually, 0.1. I think that's gonna work. Yeah, that's perfect. Okay, I think that made a very minor difference, but it doesn't matter. Okay, so we have that. Now, what we need to do is add a nice little animation to it. Now, I'll show you something cool. Okay, so we want our pet to go up and down. And the best way to do that would be using a sine wave. But the way you need to, if you guys want a visualization of that sine wave, I'll show you that right now. Okay, so you can go to this website, Desmos, and it's what I use for stuff like this. And a sine wave is pretty much a wave, and it has a value between 1 and -1. And you can change that by multiplying this constant x value, it's not really constant, by a frequency. So we can have a frequency of 2, and the amplitude, how higher down you want it to go, that can be, you can multiply the whole thing by something. That's just going to give it an amplitude. You can make it smaller or bigger. So I'm just gonna have that at 1, but as you can see, if we use this for our pet, it's just going to go up and down, is going to clip through the ground, and we don't want that to happen. We want it to go up and just not go under 0. So there are two ways of doing that. We can use max, so math.max. We can have sine x, and we can have that not go under 1, I mean 0, and that works. We can also change the frequency and the amplitude, and it will work fine. Or there is another way. We can just get the absolute value, x, and you can multiply that by a frequency, and you can also multiply by that by an amplitude, and that's just going to have the absolute value. You can use whichever you want, but I think I like the math.max one better, because if you look at this, I'm just going to do this and just limit it at 0. There's a little weight between each one, and I kind of like that. It looks like a nice hopping animation. So we could use that. So I'm gonna go back into recording studio. And before I do that, actually, I think a temporary fix for the pet that doesn't stay on the ground would be to just have an attribute added to each pet, and it's just going to be, okay, not an attribute. I could add a number value, just add a number value to the pet and just name it y offset, and we could have that at negative 0.5 or -1. We can mess around with that until we get it perfect. And in here, instead of using y offset, we can do local y offset equals pet colon dot y offset set dot value, and I'm just going to get rid of this variable up here, and let's see if that works. If I just get this pet inside of that folder, we can see that a y offset of 0.5 doesn't really, -1 doesn't really do it. So -1.2, how about -2? That goes through the ground. So 1.9, 1.8, 1.7. That's a little too much. 1.71, 1.75. I think 1.75 is perfect for this. Yeah, it is. It's pretty much perfect. That's the ground. So negative 1.75. We could use that. Negative 1.75. And this varies between each pet. You can just use whatever you want. This is a grounded pet, by the way. So we could have a value in here if the pet walks on the ground or not. So I'm just going to add a bool value, and we're just going to call it flies. or flying. And this pet does not fly, so I'm gonna keep that at false. Okay, so here's what we're gonna do. We're gonna check if the player is moving. So if character dot humanoid dot move direction dot magnitude is greater than 1, then 0, sorry, then 0, then here's what we're gonna do. Else okay, so if the player is moving, then what we can do is get the sine wave. So local walk sine wave. And that's just going to be math dot max math dot sine. We can implement what we did, and this will take time or tick. But I prefer using time, and we can multiply that by a frequency of 3. We also might want to divide it by like 2, and then we can limit it to 0. Okay. Now we can just do pet c frame equals pet actually multiply equal c frame dot new 0 comma walk sine wave comma 0. Okay. Let's see if that works. So I'm just going to get the pet, put it in here, and if I walk, as you can see, it starts doing that. And the reason why it goes all the way to the ground, actually no, it works. Wait, let me just double check. So it goes down, and as you can see, it doesn't touch the ground. Okay, it does. So that works, but it's pretty ugly as an animation. So we might want to multiply the frequency by 5, and we might want to divide this by 3. And then for this, we don't need to change that. Okay, so after messing around with the settings quite a bit, and I ended up with this. So math.max, math.sine, time multiplied by 10 divided by 2, and minus 0.1. And for this that I added, it's basically going to give it a nice effect, a nice rotation effect. Math.cos and time multiplied by 10 divided by 7, and I'll show you how that looks. Roblox is down, I think. Okay, so I'm just going to get the pet in here, and this is how it looks. It looks like the pet is hopping around. If I have multiple pets, I'll show you how to make them not do everything this at the same time, because this looks kind of ugly. So what we need to do is add a number value in here, and just call it time delay, and just have a random value in here, like 50, 60, I guess. And we could make it so that each pet has a random value when we equip the pet, but I'll show you how to do that. But for now, just each pet should have a random value in here. And what I can do in here is just add pet dot time delay dot value, and make sure to add parentheses in here, and just do the same thing here. Okay, and just type that in, and let's see how that looks. Nothing should change with one pet. Okay, it changed. Time delay is not a valid member of. Okay, let's see. Time delay. Okay, I was uppercase. These are the little things that kind of ruin everything. I'm just gonna get this pet, and let's see. So it will still work the same, but if I have multiple pets, it will still work the same. But if I had different values on each pet, like this one should be 10, and this one like 150, and this one and this one like 500, maybe like 1, and this one a time delay of 250, they should not be the same. And as you can see now, they hop at different times. And this is good for walking pets, but what if our pet flies? So if our pet is flying, then what we should do is local fly sine wave, local hover sine wave, that's a better name, equals math.sine, and that's just going to be time plus, okay, so let's just paste that in, time plus pet delay, pet.time delay dot value, and we can multiply that by 10. No, 10 is too much. By we can multiply that by 5, and we can divide the whole thing by 2. And in here, I'm just going to check if pet dot flying dot value equals false. Then, so if it works, then we're gonna do that. Else pet cframe multiplied equal cframe dot new, and we're just gonna put in 0 comma hover sine wave comma 0. Let's see. So I want to make this pet fly, so I'm just gonna check flying. Let's just take that, and now as you can see it does hover, but we might want to add the math.max. So math.max, and just do that and give it a minimum of 0. Let's see. Okay, that looks like the pet is hovering, but I don't like how it's doing this. Yeah, that's not very good. So we might want to up the frequency a bit, maybe like 10. Okay, that's just bad. I'm gonna mess around with this and I'll be back. Okay, so I ended up with these values. I'll show you what they are, and this is how it looks. So I just set the hover sine wave to time plus time delay dot value, multiplied by 5 divided by 5, and then in here I added 0.2 to the hover sine wave, and it turned out pretty good. Now, what if the pet is not flying? I mean, if the player is not walking, then I don't think we need to do anything. I mean, you could definitely do something. Maybe like else, then we can have the idle version of this. So idle, and we could divide this by we could just have this like that, and in here we can just do this plus hover sine wave idle, and we need to also check if flying equals true this time. Then we could do this. Let's see. So I'm just going to equip this pet, and since it's flying, it's going to keep on doing this slowly, but when I walk, it's going to do this faster. Now you can mess around with the settings, of course, and if I have multiple pets, if they have different time delay values, and also I don't like how high they go. That's a little too much, so we could definitely divide that by a higher number, like 8. See how that looks. That's pretty good. Yeah, that's good. Okay, so if some pet is not flying, then it should just do this. And if they are flying, now that I think about it, that's a little too fast, but you can mess around with that. But yeah, it works. Okay, so what I wanted to do was make each pet have a random value, so a random time delay value. So just set this to 0, and I'll show you how you can equip and unequip pets. So that's an important thing. We could have, so whenever you want to equip a pet, let's say we have a function name module in here. Okay, so let's just call this pet module. Okay, and what I'm gonna do is function module dot equip pet and function module dot unequip pet, and you have a folder in replicated storage, and that's going to be called pets. That's going to contain every single pet that's in the game. So I'm just going to drag that in, and I'm going to, so module.equip pet, that's going to take the player, the, okay, why can't I type player, and the pet name. And in here we need replicated storage. So local replicated storage equals game on this first replicated storage, and local pets equals workspace dot replicated storage dot pets. Okay, so what we need is same thing here, by the way, player and pet name. So local pet folder equals workspace dot pet folder dot player pets square brackets player dot name, find first child, not square brackets, find first child player dot name, and if pet folder equals new, and then just return end. If not, then local pet equals pets square brackets pet name clone, and pet dot parent. Actually, before we do that, pet dot time delay dot value equals math dot random from 1 to all the way up to 500. Okay, and actually maybe from 10 to 500. And what I'm gonna do is pet dot parent equals pet folder. Okay, now same thing in here, but instead, so pet folder find first child pet name colon destroy. Okay, so that's pretty much it. Now in here we can require, I'll show you how to use that. So local pet module, also I want this to be a walking pet. This is going to be pet 1, and I'm going to have a duplicate version of that, and this I don't want. Okay, so let's just make these pets look a bit better. This is going to be pet 1. Wait, what did I just do? Okay, this is going to be pet 1. I want that to be blue. I want that to be blue. Okay, so this is going to be pet 1, and I'm just going to put it in here. And pet 2 is going to be a flying pet. Flying true, okay. And pet 1, same thing, but flying is going to be false. Okay, so in pet server, pet module equals require game.server-script service.pet module. And when the player is added, what we can do is task.wait 5 seconds. And for I equals from 1 to 5 or 10, do pet module dot equip pet player comma pet 1, actually just 5, and after that we're gonna do the same thing. No, we can just have it in here, but this time pet 2, and I'm going to have task.wait 1 between each pet, and I'm going to play the game and see if that works. Okay, after 5 seconds I should get the first pet, and I'm not getting any more pets, so pet 2 is not a valid member of replicated storage.pets. Pet, oh, okay. So the blue one should be pet 1, the other one should be pet 2. I'm really sorry about that, I should not have made that mistake. Let's play again, and okay, I got the first pet, second pet, and as you can see, it looks pretty good. They're offsetted, and yeah, I like that. That's good. But I don't like how deep these go. So you could mess around with that. But that's really simple. I could just in here change this to 0. And now we shouldn't have that problem. Yeah, they don't clip through the ground anymore. Okay, so that's good. We have that done. Yeah, that's going to be it for this tutorial. If this helped, make sure to subscribe, like the video, share it with your friends, and I'll see you all in the next video. Bye.